For the input x, the function is given by negative 3x squared plus 5. Note that there is no x term. What are x-intercepts, if any? Number 2, what is the y-intercept? Number 3, what is the vertex? Number 4, substitute x equals x1 equals negative 2, find y1. Number 5, substitute x equals x2 equals negative 4, find y2. Number 6, find the average rate of change of the function from x equals negative 2 to x equals negative 4. And number 7, plot the graph. Rough sketch will do. Question number 1, what are x-intercepts, if any? To find x-intercepts, you set y equal to 0 and solve for x. So set y equal to 0, and solve for x. So when you put y equal to 0, you get 0 equals negative 3x squared plus 5. Can you compare this with ax squared plus bx plus c is equal to 0? Immediately you see that a is equal to negative 3, b is equal to 0, right? 0, when there is no x term, it's as good as 0x. So b is 0. And c is positive 5. So that's what I have done here. All right, so we are up to here. Now you substitute for a, b, and c. Do not forget, a, b, and c can be positive or negative. What is not possible is a going to 0. You can have b go to 0, you can have c go to 0, but you cannot have a go to 0. So substitute what we know. We have a is equal to negative 3, b is equal to 0, c is equal to 5. So negative b, so substitute for b, negative 0, plus or minus b squared, 0 squared, minus 4ac. What is a? A is negative 3, so negative 3, and then c is 5. And what is negative 3 times 5? It is negative 15. And what is negative 4 times negative 15? Positive 60. And what is square root of positive 60? 7.746. So your answer is 0 plus or minus 7.746 divided by negative 6. And that is as good as plus or minus 7.746 divided by negative 6. From which you get two solutions, 7.746 divided by negative 6 and negative 7.746 divided by negative 6. So from that we get negative 1.291 and positive 1.291. So what are our x-intercepts? Negative 1.2910, x comes first, and positive 1.2910. These are points where the graph of the curve touched the x-axis. That was the reason we set y is equal to 0 and solve for x. All right, so we plot those 2 points, negative 1.291 and positive 1.291. All right, so we are done with x-intercepts. The y-intercept is very easy. All you have to do is at the position of x, you substitute 0. So whatever terms that has x in it will go to 0. So this whole thing is going to 0. So what is left? Positive 5. So when you substitute x equals 0, you get positive 5. And that is the next one, number 2. What is the y-intercept? You substitute x equals 0. Why? Because on the y-axis, x is equal to 0. Why did we choose y equal to 0 for the x-intercepts? Because on the x-axis, y is equal to 0. All right, so number 2 is y-intercept. That means set x equals 0 and solve for y. And what is it? 5. When x equals 0, 0, 5. So you get 5 as the answer. So you get 0, 5 is your 0, 5 is the point where the graph touched the y-axis. So we plot that as well. Done with 1 and 2. Now let's do number 3. What is the vertex? Remember, f of x equals ax squared plus bx plus c. Our function is negative 3x squared plus 0x plus 5. So a equals negative 3, b is equal to 0, c is equal to 5. What is the vertex? H equals negative b over 2a. So negative 0 divided by 2a, and 0 divided by anything is 0. When we substitute h is equal to 0, what do we get? K is equal to 5. So h is equal to 0 and k is equal to 5. So 0, 5 is the vertex. So that's what I did here. All right. So we have h equals negative b over 2a, and we have negative 3x squared plus 0x plus 5. So a equals negative 3, b is equal to 0, c is equal to 5. Substitute negative b over 2a. And we get 0 for h. We are not done. We have to substitute x equals h and solve for k. And what do we get? 5. So what is our vertex? 0, 5. Vertex is 0, 5. We plot that as well. 0, 5 is our vertex. So we are done with 1, 2, and 3. So now let's do number 4. Number 4. So we have f of x equals negative 3x squared plus 5. What happens when we substitute x equals negative 2? So we substitute x equals negative 2. So in the space occupied by x, we substitute negative 2. So this is as good as negative 3 times, what is negative 2 to the power of 2? It is negative 2 times negative 2, which is positive 4 plus 5. So we get negative 12 plus 5, and that is negative 7. So that's what I did here. All right. X equals negative 2, and substitute x equals negative 2, and you get negative 7. So what is our point on the graph? It is x equals negative 2, y equals negative 7. And that is our x1, y1. Okay. So we are done with 1 through 4. So now let us do number 5. F of x, our function is negative 3x squared plus 5. So in the space occupied by x, we substitute negative 4. Negative 4. So what do we get? It is negative 3 times positive 16 plus 5, negative 48 plus 5, and that is negative 43. So when x equals negative 4, y equals negative 43. Let's call that x2, y2. Let's call that x2, y2. So that's what I did here. Substitute negative 4 for x, and you get negative 43. So what is our point? Negative 4, negative 43. Now let's do number 6. Find the average rate of change of the function from x1 equals negative 2 to x2 equals negative 4. So x1 equals negative 2. We already know what y1 is. Negative 7. We already did that, right? And now we have x2 equals negative 4. We did that as well. And what was y2? When we solved for y, what did we get? Negative 43. So what is our average rate of change of the function? It is y2 minus y1 over x2 minus x1. What is y2? y2 is negative 43. What is y1? Negative 7. What is x2? Negative 4. And what is x1? Negative 2. So that is what I did here. So you have x1, y1, x2, y2, y2 minus y1 over x2 minus x1, and I get positive 18 as my slope. All right. So we are done with 1 through 6. 1 through 6. What is left? Plot the graph, and here we have the graph. These are our x-intercepts, This is the Y-intercept and the vertex. And this is George Mathew signing off. Good luck.